Hello everybody. Here to show off the new Saturn PCB design RF tag transmitter. It can be seen in the products here. Here's a picture of an assembled unit. It is optimized for 915 megahertz using CC1101. I'm sure a lot of people are familiar with this device. It's a fantastic device from Texas Instruments. And we're using a PIC16 here to run the code for it. I can show everyone here. Here's the size of it. It's 1 inch by 1.25 inches. This is the Allegro source file, PCB design. In the Allegro 3D viewer here, this is the 3D viewer of it. I'm sorry, the view of it. Missing a couple of actual step files, but they're pretty much going to be rectangles and squares anyway. So this works out just fine. C15 is actually optional. I don't use it right now, but it's there. The device, this particular board runs off of one single CR2032. It could be changed if someone wanted to use a larger battery or the double stacked. That's fine. The firmware that we had loaded into this originally, we got 18 months out of one single battery. The firmware, we were transmitting a very small amount of data, only 4 bytes, and we were transmitting them every 3 seconds. We would put the device into sleep mode, wake up, transmit our 4 bytes, go back to sleep for 3 seconds. So that's how we optimize the firmware, and we're able to get 18 months out of it. A little bit longer, data streams, you'll still be able to get 6, 9, 12 months out of it. It just depends on how much data you're running and what baud rate you're running, which helps quite a bit to go with the higher baud rates. The sleep mode, you can see here I'm using the EEV blog from David Jones to the U current, he calls it, to measure sleep current. And right here you can see I'm getting about 440 nanoamps. And here's a description. This was done quite a while ago on an older scope, but here you can see the sleep current here and here. The device wakes up, has a spike of current to wake up, has this initialization period here, has this calibration period, which you'd have to read the 1101's data sheet. It's kind of a complex thing the device does internally. Then it sends the serial data into the device, and then it turns on the power amp and transmits. This right here, I'm at 5 millivolts per division here, so it's just about 10 millivolts, which correlates to about 18 milliamps. The way I measured the voltage, measured the current by measuring the voltage across a series low value resistor in series with the power supply. And then after it transmits the data, it goes into a shutdown mode and then into sleep mode. And we're back to there. So that is this particular device. It can be found, again, it can be found here on the products, the 915 megahertz RF tag transmitter. Again, it's a packet radio. You can configure it however you want, or we can write the firmware for you. I will have pricing and availability on the website as soon as I can. I'm ramping up production of this as we speak, and I'll get it packaged up and everybody can start ordering it. Thank you.